so you may be familiar with the word dilation already. It's like when the shape grows or shrinks. So just make a note what a dilation is. It's when the shape grows or shrinks. No, you're probably, you get the concept, like maybe you start with a smaller triangle and then it grows into a bigger one. Of course, like that concept just makes sense. But something to also note is that these two shapes are similar. Similar shapes is something we haven't gotten to yet. They changed the order of our chapters, so you haven't seen this yet. But what similar means is that they're proportional. So, for example, if this is, I don't want to use 2, maybe like if this is the length of 4, and then this is double the size, then this would be 8. And then if this length was like 3, this would be 6. And if this length was 2, what would this be? 4. So it's all proportional, and you could even set up proportions to solve for these side lengths. So for example, if they just gave me x right here, I could say, okay, 4 over 8 equals 3 over x, and then solve for this here. So if it wasn't like obvious that it's times 2, you could always use proportions to solve for side lengths. So that's just a side note. That comes up in a later chapter. With similar shapes, though, something I also want to point out is that they have the same angles. So even though the side lengths are double, the angles stay the same. So this angle would be the same measure as this angle would match this one, and then if this is like 90 degrees or something, it would match the same angle.
Is it always going to be like doubled? Or
So there's different, it's called a scale factor, and we'll look at different scale factors, but it's always proportional. Okay, so that's one concept that's in this lesson, and then we are looking here at an actual dilation. It says use the figure and point C, then use a ruler. We're not going to use a ruler to draw the figure under the dilation with center C and scale factor R. So here is C. This is the center of dilation. Center of dilation. This is like where it's growing from, and I'll show you what that means. Okay, and it says 2 is the scale factor. So it's growing by a scale factor of 2. So it's getting twice as big. Each side length is getting twice as long. But there's something else to note with this. The distance from the center of dilation is getting twice as far. So whatever this distance is, to each point, so going from the center to this point, it's going to double because the scale factor is 2. So the length doubles, so I'm just trying to draw the same length segment in the same direction. It's supposed to be like a straight line. Oh, it's blurry. Come on, focus. There we go. Okay, so again, the length here doubles, so whatever this length is from this point to this point, it's going to double in the same direction. And then from the center to this point, whatever that length is, I'm going to double it out this way. And so what we have here is the new triangle that's been dilated a scale factor of 2. So the side lengths of this triangle should be double the side length of the original. Okay. Now the next one, the scale factor is 1/4. So in this case, the shape's actually going to get smaller. It's going to be 1/4 the size of the original, but also the points are going to be like a fourth away. So if this is one whole, and I break this up into 4 equal parts, so break it up in half and then halves again. So I broke it up into fourths. The new point is going to be only 1/4 of the way out. So again, connecting the center to this point, now just kind of eyeball it, break it up into fourths, and then put your new point at just 1/4 of the way. And then here, connecting this, again, just kind of eyeball it, break it up into fourths, and put a point. And then connect the last one and make another point. So you have a square, same square, just now smaller, 1/4 the size of the original, and also 1/4 of the distance to the center. Okay, so now we're gonna practice it. Why isn't it focusing right? There it goes. Okay, now we're gonna practice this a little more over here on the other side. So just look over to the other side, and it has the same kind of problem. It does give us a fraction instead of a whole number here, but 3/2 is just 1.5. Because this number is greater than 1, the shape is going to get bigger by 0.5, like 1.5 times bigger. But also this distance here, this is 1, we can just extend it out a half more to get the point of the new triangle. So again, this distance right here, if that's 1, then extend it out another half. And then here, if this is 1, then extend it out another half of that length. Then here is our new triangle. Should be 1.5 times the size. And then for number 2, so this, because it's getting bigger, it's called an enlargement. And then for 2/3, it's less than 1, so this is going to be a reduction. So it's going to get smaller. So this time the scale factor is 2/3. So what I'm doing is I'm making that segment here, kind of eyeballing it in thirds, like breaking it into thirds, and 2/3 would be right here. Again, breaking it into thirds, 2/3 would be right here. And then the last step is just to connect those dots. And I just shrunk the shape. Okay, next concept, and it builds from here, as you probably realize. Okay, so I'm going back over to the other side. The directions say determine whether the dilation from K to K prime is an enlargement or reduction. So I already touched on that. And enlargement's when it gets bigger. Maybe you know what, let's just write it. Enlargement when it gets bigger. And the scale factor, in this case they're using R for scale factor, would be greater than 1. And then for reduction, the shape gets smaller. And R, the scale factor, would be less than 1. If the scale factor was equal to 1, it would just stay the same size. Okay, so for number 3, we're going from K right here to K prime. So going from K to K prime, the shape is getting larger, so it is an enlargement. It says, then find the scale factor of the dilation and x. Before I get to the scale factor part, something that happens in these examples is it shows you the total length from the center of dilation to K prime is 7. It shows you the distance from K to K prime is 5 and it wants to know x. Well, that's pretty easy. What is x? 2. It's just 2. Because 2 plus 5 is 7. So that's just a little part they added, but not really part of the overall concept. Okay, so now we have to find scale factor. Scale factor. And how do we do that? We take the new length, which is from the center to K prime, and put it over the original, which is this distance. Or another way to look at it, the reason why I wrote it like this is because there'll be different types of situations that we'll get to in a second, but the other way to think of it is like K prime over K. The new one over the old one. And so for this, the distance from the center to K prime is 7. And the original was 2. So therefore your scale factor is 7/2 or 3.5, however you want to think of it. So that is our answer for 3. Okay, now for number 4, we're going to continue this concept. We're looking at whether it gets bigger or smaller. So the original is here at K, and then it goes to K prime, which is a smaller shape, so it is a reduction. And then we're finding the scale factor, so it's going to be K prime over K. They did leave a value not, so this is 5, this is 2, then this x has to be 3, just FYI. So the distance to K prime is 2, and then the distance from the center to K is 5. And so since it is a reduction, this should be less than 1, and it is. Okay, now we're going to practice it on the other page. So number 3 and 4 here. Okay, so from K to K prime, it's getting larger, so it's an enlargement. X is 5. And then we're going to put K prime over K. So the distance from the center to K prime is 15. And from the center to K is 5. And so that is 3. So there's a scale factor of 3. So this shape is 3 times larger. And the next one, K to K prime is getting larger, so it's an enlargement. 2 plus 1 is 3. So K prime over K. 3 over 2. Or 1.5. Whatever works better in your brain. Cool. Okay. Last couple examples. Oh, we have 2 minutes before, I think, or what time do you guys leave? 11?
I think 11. Yeah.
Oh, actually, sea lunch doesn't start till 11:16. Okay, you're back. You have at least like 10 more minutes. Okay, cool. That means we can finish the lesson. Cool. Okay, so these bottom 2 are where we're going to actually do dilations using points, which I'm sure you realize is where we're headed. Find the image of each polygon with the given vertices after dilation centered at the origin. Most often the dilations are centered at the origin, and it makes it a little bit easier as far as these coordinates go. Here it's giving us the original shape, and then it's giving us the scale factor. We're going to graph the original first, and then we'll graph the dilation. So the original, we're just using the points to graph it. There's the original. So just based on the concept, it's saying the center of dilation is your origin. So these points right here should be going twice the distance out. So like whatever this distance is going to double. And whatever this distance is, it's going to double this way. Now what if there was an easier way to do it than trying to figure out that distance? And there is. When it's centered at the origin, you can take a shortcut. And you could multiply this whole, like all these coordinates by 2. So the scale factor is 2. So we're literally going to take all these points and just multiply them by 2. So J prime is now going to be at 4, 8. K prime is at 8, 8. And P prime is at 6, 4. And then we graph these points. Oh, bye, Madison. The video will be up soon. 1, 2. You're welcome. 4, 5, 6. 1, 2, 3, 4. B prime. Okay, so here's our new triangle. This triangle has, the side lengths are double the length as the original. And yeah. Okay, now we repeat with number 6. We're going to graph the original points. Okay, and then for the dilation, the scale factor is 1.5, so the new shape's going to be 1.5 times, so it'll be a little bit larger than this original. It's centered at the origin, so it's just going to grow from the origin. As far as the exact points, all we're going to do is we're going to multiply all these coordinates by 1.5. And you can only use this when it's centered at the origin. So D prime is now -3, 0. So if you did 1.5 times 2, you'd get, or times -2, you'd get -3. There's the new points. And there's a new shape. Now, something that sometimes happens on the homework is they'll give you this image and they'll ask what the scale factor is. What you can do in that sense is just, you could find the length of one of the sides, that would work. You could also look at the coordinates. So, for example, G and G prime is at 0, 3, and G is at 0, 2, and then you could look at the scale factor difference there. And I believe on the homework it would be like 0.4 to 0.2, so you could see that that's 2 times and just say it's a scale factor of 2. So just noting that, you can use the coordinates to actually work backwards and find the scale factor as well. Okay, now over here we have a couple examples. Number 5 is a reduction, which I wanted you to look at. It's not the best example, but we'll go for it. So A is at 1, 1, then 2, 1, 2, 3. Kind of a weird shape, right? Okay, so we have this shape here. Obviously, it's not fitting on the graph very well because when we multiply everything by 0.5, we're going to get very small numbers. So A prime will now be 0.5, 0.5. C prime will be 1, 1.5. Okay, so then plotting this reduction, it's going to be very small in the corner here. This is why some teachers don't use textbooks, because there's always like weird errors like this. It doesn't make sense. Okay, there we go. There's our reduction. Gotta love it. Okay, and I'm not going to go through this one completely, but the idea is that the scale factor is 3/2 or 1.5, and then you could multiply all these points by 1.5 to get the enlargement. And then we will go over number 7. 7 says, estimate enlarged a 4 by 6 inch photograph by a factor of 5/2. So here's our photograph. It's 4 by 6. And he enlarged it by a scale factor of 5/2. what are the new dimensions of the photograph? So what you could do is just take the dimension 4 and multiply it by 5/2 to get the new dimension. And for 6, you could multiply it by 5/2 to get the new dimension. So we'll just put 4 over 1. 4 times 5 is 20. 20 over 2 is 10. 30 over 2 is 15. So the dimensions of the new photograph is 10 by 15. Another way this could be asked, it could be asked backwards. It might give you the two photographs and you have to determine what the scale factor is. That's where that example where it's new over old or original, you could take the dimension of the new one and put it over the original and just simplify that fraction to get the scale factor. So you can work through it either way. And that's it. I'm going to have you jump on your homework. If you have any questions on the homework, please ask. When you finish the homework, do Khan Academy. Oh, and then also turn in your notes when you're ready.